Hello, so today we are going to take a look at this problem called score from flipping matrix. And essentially the problem is we have a matrix A that contains only values 0 and 1, and we have one operation allowed, which is either toggling an entire row or toggling an entire column. So those are the only operations that we can do. And toggling here means switching all the zeros in the row to 1 and all the ones to 0, and doing the same thing on a column. And so we can either do it for a column, switch all zeros to 1 and all ones to 0, or do it for a row and again switch all zeros to 1 and all ones to 0. And then we have a concept of a score of a matrix where the score is basically taking every row and considering the content of the row in binary and getting a number out of that, and then summing up the numbers that we get from each row, right? So for example, 0, 0, 1 here, that would be 2 to the power of 0 for this one. In binary, it would be 2 to the power of 0 plus 2 to the power of 1, sorry about this, plus 2 to the power of 1 plus, and that's it pretty much. So it's 1 plus 2, it's 3. So the first row is 3, the second row would be 2 to the power of 0, 1, so this is 0, and then 2 to the power of 2, 4, plus 2 to the power of 3, which is 8, so 8 plus 4, that gives us 12. And here, this would be 2 to the power of 0, that's 0, to the power of 1, that's 2, plus 2 to the power of 3, which is 8, so that gives us 10 here. So overall, the result would be 3 plus 12, which is 15, plus 10, which is 25. So that would be the score. So the score is taking each row as a binary and getting the number and then summing up all the rows. And the goal of this problem is to return the highest possible score after doing any number of these allowed operations. So we can toggle a row or a column as many times as we want, but the result that we want is the highest possible score that we can obtain from doing so, right? And so for example, with this input here, the highest value or the highest score we can obtain is 39, and that comes from transforming this array here yeah, pretty much 39 is the highest score, but let's see how we can get that by transforming an array and getting a value like this. Okay, so how can we approach this problem here? So the main idea is that for binary, we know that let me just change this here. So with binary, we know that 1 0 0 is bigger than 0 1 1 1. We know that 0 0 1 here is bigger than 0 1 1, right? So what this means basically is that the most significant bit always gives a larger value, right? Always gives a larger value when set to 1, right? And if we go back to the problem again, we know that what we are looking for is, so given an A like this, 0 0 1 1 1 1 0 0 1 0 1 0, we want to transform it in a way, so we want to transform it to something here, right, with some values by toggling, and then so this would be row, let's say 0, row 1, row 2. We want to convert from binary, right? And the array would be considered a binary value R0, and then we add converting from binary for this row, the second row R1, and then do the same thing for row 2, right? So that's what we are looking for, and we have this insight that what matters is that it matters most that the first column has 1 values, right? So to get a higher score, the first column has to have only ones, right? So we need to prioritize the first column to have only one. So how can we do this? Well, we can just, for the step one, for each row, if the element at that position, at that row, at position 0 is equal to 0, then toggle row, right? Because if we toggle the row at that point, we would get 1 in the first position, and that what matters the most, because no matter what's behind, like if we had 1, 0, 1 like this is still bigger than it. If we had, this is 1, 0 is still bigger, and if we had 0, 1, 0, 0, 1, 0, 0 is still bigger. So any other bit, the only ones that may be better is this one, right? But we have to have the first element as 1, right, to get a larger value. So we know this is the first step here is just go through the rows. If we find one where the first value, the value in the first column is 0, just toggle the row so that we can get 1 there, right? Okay, so that's the first thing. Okay, once we optimize for the first most value, then for the other ones, what we want is to get as many ones as possible, right? So one thing to mention here is that this is a greedy approach, right? Because we are kind of doing an a local best choice, and that gets us a maximal, like a global best choice, right? So this is a greedy approach. And so with 1, 0, we want to maximize the number of ones as possible after doing this for each column, right? But we know that we want the first column to only have 0. So that means skip the first column. We are not going to toggle the first column, right? We already took care of looking at each row and toggling them. It doesn't make sense to look at the rows anymore, but we want to optimize the columns now, right? And so how do we optimize the columns? Well, it doesn't matter for the column at which position 1 is, right? Because they are at the same position. We are here, something like this, right? It doesn't matter if we optimize this row or this row, right? What matters is that we have as many ones here as possible, because that would improve the score for every row, right? So the goal for each column is to have most number of ones, right? And the only operation we have is toggling. So what this would mean is that we could just check if count of ones in column are less than the size of the column divided by 2, right? What this would mean basically is that there are more zeros than ones in the column, right? Which means if we toggle, we will have the reverse. We will have more ones than zeros, and that's exactly what we are looking for. So this would mean that if we toggle, we'd have more ones than zeros, and this is exactly what we want. So basically, just check if the count of ones is smaller than the half the size of the column. That means there are more zeros, so we toggle and we end up with more ones, and do this for every column except the first one, and that will give us an additional optimization layer, right? So let's summarize this here. So step 2 would be for each column except column 0, check if count of ones is smaller than the column size divided by 2, then toggle the column, right? And pretty much that's it for the second step. Now we optimize it for the rows, we optimize it for the columns. There is nothing else we can do. Now we calculate the score. So step 3 for us would be to calculate the score. Now, how can we calculate the score here, right? So one thing we know that, so if when I took 1, 0, 1, 1, we know that this is equal to 2 to the power of 0, that comes from this one, plus 2 to the power of 1 comes from this one, plus 0 multiplied by 2 to the power of 2, so we just remove that one. And here, this is 2 to the power of 3, right? And so you could see here, this 0 here comes from if we say like the size we have, for example, let's say the size of columns, or let's say that columns is the number of columns as a notation here, and let's say rows is the number of rows. So what this would mean here basically is that what I'm doing here is basically columns, right, minus the position, right, let's call it G minus 1, right? So this would mean here G is equal to columns minus 1. So what this would mean is columns minus columns plus 1 minus 1, which is 0. For the second one, G is equal to columns minus 2. So this would mean columns minus columns plus 2 minus 1, which would be 1, which is why we got 1 here, right? For this one, this is J equal to 0, right? So we will get just columns minus 0 minus 1, which is columns minus 1, and columns in our case here, it's the number of columns is 4, so 4 minus 1, so 3, right? And so we have a formula here to obtain the value for each position, right? So we could just say, to calculate the total, we could just do 2 loops, right? So we could just do total, start out as 0, and then do a for loop for the rows. So this would be rows, and then do another for loop for the columns. And then for the total, we can just add with, there is just one caveat, is we want to count only if it's 1, right? Because if it's 0, we should skip it, because that's 0 multiplied by a value, that's just 0. So we can say here, if aij is equal to 1 only, in that case, we will add it to the total, right? So the total is 2, right? To the power of, in Python, to the power of, we could just write it with 2 multiplication signs. And it's columns minus j minus 1. This is the formula we said. So it's columns minus j minus 1. And that would be pretty much it for the third step, to calculate the score. And that would be pretty much it. So 2 steps first, using greedy. The first one is if the first element of the row, which means in the first column, if any element is 0, we need to toggle the row. And then the second step, for each column, apart from the first column, of course, because we already handled that, if the number of ones is smaller than the size of the column divided by 2, that means we have more zeros, so we toggle and end up with more ones, right? And then once we do this transformation on the matrix, we calculate the score, and the score is just going through every cell in the matrix and adding the value that cell contributes if its value is equal to 1. And that's pretty much it for the solution. So we will need for the implementation a more detailed solution where we implement the toggle itself, right, for the row and the column, but this is the main idea here. So let's start writing down the algorithm here in detail. So this is what did we call the score flipping matrix? Let's call it so, score flip matrix, and we get the matrix A as input, right? And so here with this, we need we know we need a function to flip, right? We need a function to flip the row. So let's just define it here. So this will need to flip the row. Let's give it some space, and then we need another function to flip the column. And give it some space, and then after that I'm just going to have the value of rows and columns defined. So this is rows is the length of A, column is the length of the first column, for example here. And now we need to do this, the first step, right? Step 1. So step 1, which was like greedy on first column by row, right? This is kind of my summary of it. And so we can, to do that, we just go through every row, right? And check if the element at the first position, so the first column of that row, is equal to 0, then we toggle, right? Or flip the row, right? So we need to call flip row here. So flip row at position error, right? And now we do the second step, right? So the second step here is to for each column except column 0, right? If count 1 is smaller than columns divided by 2, then toggle, right? This is the second step we said. So to do that, we are going to go through the columns except the first column 0 at position 0. So that would mean range of 1 columns, right? And what we are going to do here is we are just going to sum up the number of ones, right? So let's call this ones here. So it starts out as 0, and then we go through every position in the column. So that would mean we will do for I in range of rows. And then we could just say the number of ones is plus 1 if aij is equal to aic, the column is C, is equal to 1, otherwise 0, right? We could optimize this by just adding aic because 0 won't add anything, but for now let's just make it explicit like this. And then after we do that, we are going to check this condition here, if it's smaller than the size of the number of columns divided by 2. So if the number of ones is smaller than size of columns divided by 2, that means we need to flip so that we can get more ones than zeros. And so we call that, which is flip column for column C. And once we do this, we do the third step, which is to calculate the score, right? So step 3 here. Which would mean that we need the total value, right? We already know the formula here is to go through every row in range of rows, and then we go through every column, and we add total if, basically we need to do if the value is 1 only that we counted. So the same thing we did here, right? So if it's equal to 1, then total is going to be 2 to the power of the formula that we said, which is minus j minus 1. And then at the end, we could just return total, right? And with that, almost everything is defined except these two, flip row and flip column. So flip row, we need just to go through every column position in the row. So for C in range of columns, what we need is just to set the value to 1 minus what was before, right? Because with this, if the value was 0, it will end up 1. If the value was 1, it will end up to 0, so it would be equivalent to toggling, right? Or flipping the bit. And we do a similar thing for the column, except now we need to go for every row. And we do the same way of toggling here. And that's pretty much it for this solution. And so one thing we should take a look at here is what is the overall time complexity for this solution. So we can see definitely here we are doing O1 here, and then we are doing for every flip row, we are doing also O of, let's say columns is M and rows is N, right? So for the flip rows, we are also doing O of M, right? So this is O of n M, right? And same thing here, we are doing O of M for the column, but inside we are doing flip column, which gives us O of N. So here also it's O of N, M. And same thing here, overall, this is O of N M. So overall, in terms of time, this function here, time complexity is O of N M. N is the number of rows and M is the number of columns. What about space? So is there any additional space we are using here? We are just using some variables, but no extra space. So we could say that this is, everything else is done in place. So this space here is just constant. Okay. Okay, so now let's just write this down, optimize it a little, and run it on some test cases. Okay, so I wrote here the same solution we saw in the overview. So the main thing here, let me just modify this to match the naming we did earlier. So what we have here is we define the rows and the column sizes. Then we do the step 1, which is if a row starts with 0, we flip it so that we can get it to start with 1. And then we do the second step here, which is for every column except the first column, because we already handled that here. We count the number of ones, right? And if the number of ones in that column is multiplied by 2, or let's match the overview, which was if it's smaller than the number of rows which is in the column, which is the size of the column divided by 2, then we flip the column, right? And then we calculate the total. And here what we did was 2 to the power of columns minus g minus 1. If the value is 1, then we count it in the total, or let's call it maybe the score, right? So that's the same solution. Now let's run it on some test cases and make sure they all pass. Okay, so all test passes here. We can test it on more, but this should give us an idea. Now a small improvements we can make here is that, for example, here there is no need to do the if else, right? Because we could just add the element. If it's 0, nothing would be added. If it's 1, 1 would be added, right? The other thing here is we could do multiply and just not make sure that 2 times the number of ones, if it gives us less than total number of rows, that means there are less ones than zeros, so we want to flip. So this gives us the same thing. The other thing here is instead of doing 2 to the power of that, we could use binary to calculate the same thing, which we would do by just doing this. And this here, to flip or toggle the bit, we could also use something like this, right? But this should be good enough. Another thing is here, instead of checking if it's equal to 1, we could just multiply by this value, because if it's 0, then we would add nothing to the score, because 0 multiplied by anything, that would give us 0. And so if it's 1 now, then we'll add this value. So this also makes sense. And yeah, so those are the optimization we can do. Let's run this, and all test cases pass in this case. Yeah, so that's it pretty much for this solution. One thing to be aware of is we actually can get away with not modifying the matrix itself by just calculating what values would be if we had changed the matrix and not really changed the matrix. So that's one way to solve it, but I think this is a good enough solution. So yeah, thanks for watching and see you on the next one.